Diving right in on this CVH chiller, we're going to come up our suction line and into our suction elbow off of the evaporator. This is going to go straight into our suction nose cone where we hit our IGV. This is actually our first stage of IGV. IGV stands for inlet guide vane, where we then pass to our first stage impeller. And we're going to pass through this first stage up into our diffuser. This diffuser is going to feed directly into the second stage. Then this second stage, depending on if we have a CVHE or CVHF, will be a fixed or variable guide vane. So the difference between a CVHE and F is how many stages we have in the compressor. What is depicted here is a two-stage compressor, meaning that we have two impellers. You can see one, here's the second one back here, and then it's going to go straight to the condenser. A three-stage or CVHE or G, you would have three impellers here. So in a CVHF with two impellers, it's two-stage. The second guide vane is a variable guide vane. That is the armature that sticks out the side here that's controlled by the actuator. In a CVHE or G, the second impeller has a fixed guide vane, then it will flow through its impeller into its diffuser and into a variable guide vane for the third stage impeller before it cycles around and goes out the discharge. I'm holding, by the way. We got a lot to cover here. We're going to be going over a refrigeration cycle, the primary cycle specifically for a CVHE/F chiller. We're also going to hit on a duplex here at the end of this, which is a CDH. I'm with chilleracademy.com and HVAC Time. Over at Chiller Academy, we do trainings like this all the time. I've got a full intro course if you're interested in that. We have a lot to discuss here. I need to move very quickly through this, so just do your best to keep up. Go back, rewind, do what you got to do. There will be later videos on the secondary refrigeration cycles and oil cycle separate from this one. To give you another view of what those impellers are, this is our suction line in this open area here coming into our impellers. These are the impellers. This is your rotor and your shaft. Your first stage guide vane would be here, first stage impeller. You'd have a second stage guide vane here, which this being a two impeller CVHF. And this is the same schematic, but for a CVHE or G series. Your first stage IGV here, going into your first stage impeller. You'd have a fixed guide vane for your second stage, and that would flow into a variable guide vane for your third stage, and then out your discharge line into your condenser. Just to give you another depiction of what it looks like between a CVHE and F series. The refrigerant leaving the third stage impeller will hit your volute, which is your discharge line that comes into your condenser. This superheated discharge gas will feed in and hit a upper baffle, which will distribute that gas across the condenser tubes. Your water is inside the tubes. This is a shell and tube heat exchanger, and your refrigerant is on the outside of the tubes. The superheated gas will stack in here in the top, and as the water flows through the tubes, it will begin to take in heat from that gas, and it will allow it to enter a state of saturation and eventually convert to a full liquid refrigerant. These particular condensers don't take any kind of subcooling. It will be a fully saturated liquid refrigerant flowing out of here, but it will not have any form of subcooling. The point of this condenser is to allow the condensing gas to fully saturate down into a fully liquid state and drain out as it needs. There's nothing fancy going on here. This is a very basic setup. There will be a saturation sensor in the liquid line. That is how the chiller is able to determine its saturation temperature, is because this refrigerant leaving is going to be at a saturated temp. That liquid line from the condenser flows into this first stage orifice plate. We will flow through this orifice plate. This is just a fixed bore metering device. It's all you have to think of it. It's just a plate with a whole bunch of holes in it. And that refrigerant flows through here into our economizer. This is a economizer you would see on a CVHF. So our point here is the refrigerant's going to flow in. It's going to pre-flash here, and this is going to be a medium pressure state. Coming from our condenser, we're a high pressure liquid refrigerant. Flowing in here, we're a medium pressure saturated refrigerant. Our liquid from the flash is going to stay here at the bottom and collect, and our flash gas is going to flow. It's going to hit in between our first and second stage. Coming up to this example, we can see our refrigerant path. We come down our condenser through the orifice plate and into this economizer. As the flash gas pulls up in between these, so it's a interstage suction that's pulling in, meaning that we don't have to pull all of our refrigerant through the full stages of the compressor. We have a intermediate, we have a middle stage that's able to pull in at a higher pressure, which reduces our overall work and load that the compressor has to do in order to achieve leaving water set point. The whole point of this entire refrigeration cycle is to get the evaporator to achieve a leaving water set point to maintain their space conditions. After the refrigerant passes through the economizer, it then flows directly out into the evaporator. On its way to the evaporator, it will flow through a final flash plate where it will convert from a medium pressure liquid refrigerant to a low pressure liquid refrigerant. It will have some additional flashing from that point, but it will be minimized due to a large portion of that flash happening at this middle pressure state. Now this is a little different when we get to a CVHE series. So we're going to pull liquid in from the condenser. That high pressure liquid is converting to a medium pressure saturated refrigerant up in here, and to our first chamber. This first pressure drop chamber, we will go to a medium pressure, but it's a little bit of a higher pressure than we saw in the CVHF design. And this is going to pull up into our third stage impeller. We can see here coming out the condenser, we hit the flash plate, we come up, and then we pull into our third stage. This is our final stage of the compressor cycle before it gets pushed back into the condenser. So we will have both of these chambers are considered a medium pressure at this point, but it's still a higher pressure. Now, as the flash gas gets pulled into the compressor, the purified liquid refrigerant is going to be pushed through another orifice plate there at the bottom of the economizer. So as we come through, we go through this bottom chamber, through another orifice, and we're going to have a second stage of flash off. In our second stage of flashing, the refrigerant will then pull up into the second stage impeller, very much like what we saw with this CVHF. Going through this multi-step process helps improve our overall efficiency and our usefulness of our economizer, which makes our liquid refrigerant going to the evaporator more effective. And by doing this, we further reduce the total work the compressor has to do, and by returning the suction gas back into the compressor at a medium pressure state, it has to do less lift on the compressor to increase it to a condensing pressure. And then we will leave the economizer back to the evaporator, where we will have yet our final stage of flash, and then we enter the evaporator. I need to quickly show you this PE chart, pressure enthalpy, specifically here at the economizer section, what the economizer is doing, and this is for a CVHF specifically. We leave the condenser at 0.6 here. This is our liquid line where we're a high pressure liquid refrigerant. When we go through the first flash plate into the chamber, we are then in the economizer at 0.7 where we're a saturated refrigerant. And anywhere in the middle here we're at saturation. Over here we're at subcooling, over here we're at superheat. This is our discharged superheated gas flowing from the outlet of the compressor into the condenser over here. So part of what that suction line does, or that economizer line does, coming back to the compressor, is it pulls that flash gas off of that liquid refrigerant, which lowers its total enthalpy and allows that liquid refrigerant to return to a fully liquid state before getting sent to the final flash plate at 9. If that didn't happen here, and this was just a straight flash from liquid saturation leaving the condenser getting to the evaporator down here, there would be a lot less effectiveness of that liquid refrigerant before it gets, once it gets to the evaporator to then process through. So the whole point of that is by removing that flash gas, we're able to drop the enthalpy down and get a more effective refrigerant. Now, to show you what this looks like from the CVHE perspective, or CVHG, we leave our condenser high pressure liquid. We hit here to this point. This is where we go through the first flash plate in the high pressure side, or the high side of the economizer chamber. We pull that flash gas off. We go through the second stage flash on the low side of the economizer, and we pull that flash gas off, each time returning that liquid refrigerant to a fully saturated refrigerant and dropping the enthalpy. And then we're able to actually send it to the evaporator and have far more effectiveness. And you can see the difference if we just go straight from this point number 6 straight down and over versus where we land at number 1 over here. There's a lot of enthalpy reduced on that refrigerant, which really helps increase our effectiveness of our refrigerant, while also reducing total load on the compressor. Leaving our economizer at a medium pressure liquid refrigerant coming into our orifice plates. these orifice plates. There's a dual stack here. This comes back into load control. So that's not the scope of today's video, but essentially higher load, lower load will affect how these flash off. Either way, we enter the bottom of the evaporator. This is a flooded evaporator. Our refrigerant is on the outside. This is a shell and tube heat exchanger, and our water is inside of the tubes. We come into this distributor at the bottom of the evaporator. This is this rail that sits underneath the tubes. This will make sure that all the liquid refrigerant coming in gets distributed across the full length of the evaporator. It will then flow up and hit the tubes as a saturated refrigerant, and we want to make sure that we're pulling across the entire length of the evaporator. So there is this eliminator. This eliminator does two things. Where our suction line is up here, it makes sure that that particular spot doesn't get more pulled than the rest of it, so that it literally doesn't raise up and start pulling refrigerant off the top of the evaporator back into our impeller, which is very bad. It's the same concept as flooding the compressor. So having this eliminator, it's really just a wire mesh screen at the top of the evaporator, forces the refrigerant to have a more even pull across the entire length of the evaporator, ensuring that we get full effectiveness of that evaporator as a heat exchanger. Because without that eliminator, this section right here would be favored because of its direct location to the suction line, and we would not get the full length of the evaporator fully pulling to the degree that we want to. But leaving the evaporator, we hit our suction inlet, we flow right back into the compressor, and the cycle starts over again. One of the requests I got was a refrigeration cycle for a CDH. This is it. The main difference being is there's two of these systems sandwiched together. Let me show you. So with a CDH, it's quite literally just, here's one CVHF, here's a second CVHF. These could be CVHGs as well, which would be a 3-stage, and they're just smacked together end to end. The heat exchangers are just welded together on the same end plate. Water flows through, everything happens just the same. And these are two independent circuits. They operate independent of one another. They do not cross their oil circuits, refrigerant circuits, or anything else. They are fully separate from one another. And that is your primary refrigerant cycle for a Trane centrifugal chiller. If this is helpful, go check out chilleracademy.com. See what other stuff I got over there to help get you the education you're looking for and become the chiller technician that you want to be today. With that, MTT, make time for your family, for your spouse, for your kids. I'll see you later.